So today I'm tackling a problem that my home lab has been facing for quite a while now. I am completely out of ports on all of my switches. It's basically true. I have about 4 gigabit ports left, but no more PoE ports. All of those are used, and no more ports that are greater than gigabit. So that's the real problem I have today. So if you take a look at my past home lab tour video, I'll probably put it up there or something. My core switch in my network today is a Mikrotik CRS328. So that's a PoE switch with 24 PoE gigabit and 4 SFP plus 10 gig. So really, I need a switch that can deal with my 2.5, 5, 10 gig multi-gig RJ45 stuff, and also has some 10 gig ports that I can use to trunk between my switches or to connect to my fiber lines that I already have. So today I've decided to phone a friend, and he's going to help me out with a solution to this problem. So if upgrading my network sounds good to you, then come along on this adventure.
Hello Andrew, how are you today?
I'm doing well, thank you.
I have to admit to you, I'm one of your followers, and I'm glad you're able to speak to me today.
Oh yeah, no problem. I always love talking to companies and people that work in the industry.
Well, you said you have a home lab of your own?
I do, and would you like to see some pictures of it?
Yeah, definitely. Tell us more about it. What do you have there?
So this is kind of what I got for my network right now. So it's a little bit of a mess, but it's also extremely full. So I have a CRS328, which is one of your switches that's kind of acting as my core switch. And then I have an unmanaged D-Link switch that's just giving me more ports. And pretty much every single port here is full of stuff.
Cool, so you could definitely use like another switch so you have more ports.
I definitely could. So the CRS328 I've had for, I don't know, probably about 6 years now. I think I got it in like 2018. I was hoping to upgrade my network to 10 gig back then between my file server and my desktop. And I actually hit a snag doing that upgrade because all the cabling in my house is Cat5, not enhanced, just regular Cat5 from the 90s. And I was unable to get 10 gig to run over that with the SFP plus transceivers. The other thing is that I have a bunch of devices now that are 2.5 gig. And all of these things here, a lot of them are set up at 2.5 gig. Because that's common on a lot of new consumer equipment. So I have a mix of like used enterprise and new consumer equipment. And a lot of consumer stuff now has 2.5 gig. So I'd like to be able to mix in some 2.5 gig and some 10 gig. And I have the option of doing fiber as well. So I have some fiber stuff now mostly because the fiber network cards are cheaper than copper network cards at 10 gig.
Awesome. So I think to sort of future-proof a little bit, we should get you a 10 gigabit switch. And we actually have this one switch that has combo ports, so you can switch between using optics or Ethernet, wired like a copper Ethernet if you need to.
Yeah, that sounds great. I think it's a 12-port switch, right?
Yeah, it's a 12-port switch, and 4 of them are combo ports.
CRS312 4C plus 8XG-RM. So another reason to use optics for me is that I already ran optics from my basement to my laundry room. My laundry room backs up to my office, so I could run additional fiber from the laundry room to my office if I need to. And I ran this a couple years ago when I was pulling some new wire through the attic because it's a lot of work to do that, and I might as well pull more than one wire at a time. So I ran a single fiber, which means I have to use what's called like a bi-die optic or bidirectional optic. It uses a different wavelength in each direction. So I have a set of this running at 1 gig now from my CRS328. I have a media converter going from 1 gig fiber to 1 gig copper. And then I actually have a 100 meg switch somewhere in that pile there because it was really cheap and I had it laying around. And I'm just connecting a bunch of like IoT gateway kind of stuff in my laundry room. So my laundry room's close to my office, and with the IoT gateway stuff there, it just needs like basic Ethernet. But if we could carry through like 10 gig fiber onto the office, the room next door, then this fiber line would help me run 10 gig to my workstation.
Awesome. We can, I think we can definitely find another small switch that will do that task perfectly for you. So I think we're just going to need to go ahead, get the equipment for you and ship it over to you as soon as possible. And I think it will be quite an interesting experience to see how you can take that and implement in your home setup.
Yeah, definitely. So looking forward to adding some new stuff to my rack as always. I redo it kind of often, so.
Awesome. Well, it was nice talking to you, and can't wait.
So Druvis has made a video on Mikrotik's own channel talking about their side of the story, how they packed up my switches for me, things like that. If you're interested in seeing their perspective on this whole story, go ahead and check out their video, link down below, or maybe up here, something like that. So my package has arrived all the way from Latvia. Now I can open it. So I got a small box. This guy is the small CRS. What is his number? CRS 305 1G 4S Plus IN. And the big boy. This guy is the CRS 312 4C 8XG RM. All of those numbers mean something. Mikrotik codes like the number of ports. So the CRS 312 has 12 ports. 4C are 4 combo ports. 8XG are 10 gig ports, 10 gig copper. So that's what the switch is. First on the unboxing list, the small switch, Cloud Switch series. So this guy's got my default password because every unit has its own unique password. And I guess the quick start guide in a bunch of languages. So this guy is all metal. I believe he's passively cooled as well. There are all these vent holes in the case. So that's nice. We got dual power supply inputs. I can take a huge range of voltages here. What else? You can wall mount it, which I might do actually. 4 SFP plus, these are 10 gig, and 1 gig copper, which you can also use to PoE power the switch, which is cool. So this switch is going up in my office near my computer. So I already have a fiber that goes most of the way there. So I need to extend that fiber on a little bit. Then I can connect the switch and my computer and other stuff if I'm testing something at like 2.5 gig or 10 gig upstairs. Perfectly great for that. Then I can use the 1 gig port to loop back Ethernet to the laundry room where I have a bunch of IoT bridges and stuff. That only needs 100 meg, so it's fine on 1 gig. And now for the big one. Also a Cloud Switch series. Mikrotik calls both of these guys their CRS or Cloud Router Switch family. These guys run the full-on router OS, so you could ask them to do anything Mikrotik supports in software. They're not restricting anything based on like hardware level or licenses or things like that. So if it supports router OS, it supports the full feature set. But that doesn't mean you're going to do full table BGP on something with this much memory. So it will let you do it. That doesn't mean that it's a good choice for that. Okay, I got my default password. I got 2 power cables because I got redundant power supplies. Rack mount brackets. And the switch itself. This is really quite beautiful. So these guys here are 10 gig. They do support multi-gig as well, so 2.5, 5 gig, 1 gig. These guys also support multi-gig, but you can instead use one of the SFP plus ports instead. So these ports are called combo ports, so you have 1T or 1F, 2T or 2F, etc. So you can use 12 ports at a time. I'm going to be using these guys for fiber, I think, so I'll have 8 of these 10 gig, 5 gig, 2.5 gig RJ45s to use. There's also an out-of-band management port. I think this one's 100 megabit. That's dedicated right to the CPU, and an RJ45 serial console. If you want to do like really out-of-band management. Backside, we got the usual fans and dual power supplies. These are multi-voltage, 50, 60 hertz, good stuff. So I'm going to set this guy up on the bench here, and we're going to demonstrate some of the switching and routing features it has, the stuff that I'm going to use on my network. And so let's get on with setup. So here's a web page for the switch. If I scroll down to support and downloads here, they have a block diagram. So Mikrotik provides this for basically all of their products. So it shows us what data paths we have within the switch. So we have 4 10 gig Ethernet that goes to a 4x transceiver. We have 4 more that goes to another 4x transceiver. And then we have the combo SFP plus and the combo 10 gig, which share these 4 10 gig lanes to a 12-port 98DX8212 switch chip. So this is what does layer 2 and layer 3 at line rate. It's very fast. But then we have 1 gigabit from the high-speed switch chip to the CPU. And this is a QCA 9531L, which is an ARM CPU. It has 100 meg to the last ether port, the management port. So this one would not be good for like high-speed anything because it's going through the CPU. All the other I/O goes to the CPU. So if we have any applications that take our traffic up into the CPU, we're going to be bottlenecked by this 1 gig link here and by the 650 megahertz CPU. But if we can keep all of our I/O onto the switch chip, which layer 2 and layer 3 can do, then we get non-blocking wire speed performance. So I got the CRS down here on my bench to demonstrate that hardware routing capability. So I'm set up here with a direct attached copper cable. It's a twin-ax cable. One of the combo ports going to my test system over there. I've got another one going to my CRS 328 in the back. That's my current core switch this is going to replace. And I've got 2.5 gig out to my workstation because I couldn't wait to have higher speeds. So coming over here to Winbox, by default, out of the box, it comes up just as a regular switch. So I've got Ether 1 through Ether 8. These are my 10 gig ports. Ether 9 is the boot management port. And then the combo ports, so you can see some of them are up. These 3 ports are up. And they're all bridged together as the switch does. So I pop open one of these for a second to look at the traffic. We're doing not a lot of packets per second, not a lot of kilobits. So if I start an iPerf test, going over the link, we can see we jump right up to 10 gig. And we just kind of saturate that, which is what we expect. It's a 10 gigabit switch. It should be able to handle that, and it does. So we go right up to 10 gig. We do the test. We're done. The end. So obviously you can handle being a normal layer 2 switch just fine. But what if I have 2 servers on separate VLANs and I want them to route between each other? And that's where the layer 3 hardware offload comes in on this. So a lot of higher end switches have layer 3 capabilities. Mikrotik's entire CRS 300 and 500 series has hardware routing capabilities. However, this is hardware routing, layer 3. This is not a firewall router, and this is not going to do stateful firewalling. That has to be done on the CPU. Router OS will let you do that for sure, but it'll be a bit slower. So I set up a new VLAN interface here, VLAN 9. I gave it an IP address, and I set up the switch as a router. So at this point, I'm just routing in software on the switch CPU. But these switches are not designed to do like line rate firewall routing. That's not what a switch is for. So what kind of performance do we get? Okay, so somewhere in the range of 250 megabits per second. So that's not very good for 10 gig. We've also completely pegged our CPU down here at 100%. Well, now the test is done, but... So yeah, we're clearly limited by the CPU when we don't use the switch chip. So I did a little bit of configuration changes, and now these guys are hardware routes, so they have an H on them. So they're pushed down into the hardware. So that's my local subnet, my test subnet, and my default route. So let's see what the iPerf looks like now. It's like we're shooting up to 10 gig. Our CPU usage is 10%, 7%, not bad. So now that the hardware is handling routing, it can handle a lot of routing. So if you're building a highly layer 3 network, for example, you could use these switches to do lots of hardware routing. If you're doing a data center where every single connection is layer 3 with BGP, for example, I know some people love that, or OSPF or ISIS or whatever. Mikrotik doesn't have ISIS entirely finished yet, but it's in development. OSPF v6 works great. BGP works great, obviously. So of course, if you guys want to see me build like a Kubernetes cluster that's all BGP, this switch would be the one to do it. So now I'm going to go ahead and put this guy in the rack, and then I can set up the other switch. So I should probably get some shorter DAC cables here, but I don't have them yet, so onto the fiber. So I'm up here in my laundry room. This is where I have a bunch of IoT gateways and stuff. This is where I'm putting the CRS 305. So I already have a fiber that comes in here that's BiDi. I'm going to convert that from a 1 gig to a 10 gig. Then I bought a new standard duplex fiber that I'm going to run up through the conduit and over to my office area. It's just the next room over, but the shape of the roof pitches kind of intersect in a way that makes it a bit tricky to get that fiber through. So maybe I'll take video, maybe I won't. It's kind of cramped up in the attic. So that fiber run did not go very well. You can see my drill bit ended up in exactly the place I was hoping it didn't. But I got the fiber run, so let's carry on. Here's the stuff I got for the upstairs setup. So I've of course got the Mikrotik CRS 305. This is a Supermicro branded Intel 10 gig card. It's equivalent to an Intel X520 DA, so 10 gig direct attach. I've got 2 sets of transceivers, so these guys are going to run from my desktop to the Mikrotik switch. These are 10G LR optics, so they're 10 kilometer. I did verify that these receivers won't get blown out by their own transmitters with 0 insertion loss. So I'm running a really short fiber, obviously not even close to 10 kilometers, but these are still within spec. Now the optics that are going to go from the CRS 305 here down to the basement, those are these guys, which are BDLR bidirectional. So I flip them over, you can see they only have one LC connector, so they use a different wavelength of light in each direction, and they're color coded. So one is blue and one is purple, and so you can tell which one's which. So this one transmits on 1330 and receives on 1270, and then the other one transmits on 1270 and receives on 1330. And these are also 10 gig optics to replace the bidirectional 1 gig optics I have right now. So put the BiDi optic on SFP1, and we'll put one of the LR optics on SFP2. That'll have 3 and 4 for later. And this guy can go to the 100 meg switch that has the IoT stuff on it. I'm initially going to power it with this power brick that it came with because I don't have a UPS up in my laundry room. But because this thing takes such a wide range of inputs, 12 to 87 volts, I can get like a 4-cell LiPo to power this. That'll be, I don't know, like 14, 16 volts, which will be perfect for keeping this running through power outages. So I had this Asus XG C100C, which is a 10 gig copper card in here for testing, but now I need fiber, so onto the Supermicro. So the switch came up in Winbox, now I just got to configure it. This guy's going to be SW4. We are not going to do IPv4. And we are going to accept RAs, which should make us do IPv6. So SFP plus 1, that's my link to the basement, it is running at 10 gig. And SFP plus 2, that's my link to my desktop, that one is also running at 10 gig. Ether 1 is my little hub for IoT stuff, and it's running at 100 meg, which I expected. So now that all my links are up and running, it's time to configure VLANs on these switches. So both of these switches come out of the box as a very basic Ethernet switch. So VLAN filtering is disabled. If I want to enable VLAN filtering, I have to set up which VLANs are on which ports. So I'm going to do that now. So I'm on the small switch, switch 4, just for reference. I could come here and I could rename these guys if I want. So I'd call Ether 1, Ether IoT stuff, for example, if I wanted. Or I can add a comment here just for reference. It just depends on what you want to do. I'm going to do the comment method. So I left it named Ether 1, and I added a comment. Same for this. This is the uplink, and that's the workstation. So we need to put IoT stuff on VLAN 9 and workstation on VLAN 1. And this is going to be a trunk port with both VLANs 1 and 9 tagged. I'm also connected using Winbox over the MAC address, by the way. MAC telnet is very useful when you're doing this kind of work because as you're adding and deleting IP addresses from different interfaces and sub-interfaces, you can get yourself locked out really easily. If you're connected over the MAC address, that's much less likely to happen. So I'm going to come to the bridge menu, and I have a default bridge, and that bridge is bridging all the ports. So on the bridge, I have Ether 1 and the 4 SFP pluses, which makes perfect sense. So I'm going to go into the bridge, and I'm going to turn on IGMP snooping, and I'm also going to turn on VLAN filtering. And here I can choose if I want to use standard 8100 VLAN tags, or if I want to use service tags. So I'm going to use standard 8100 VLAN tags. In this case, my PVID will be 1, and we can choose if we want tagged or untagged. So we'll leave that there for now until I'm done configuring it. So we can go from bridge to bridge ports. These are the ports everything's on, so we can change the PVID. So that is the untagged port number ID. So in this case, this one needs to stay on port 1, so that's correct. This one needs to change over to port 9, so I can just change the PVID here to 9, and now untagged traffic will be on port 9. Then I can come on here to VLANs, so bridge, ports, VLANs, and this is showing me what's going on. So now untagged, I have VLAN 9 on Ether 1, and untagged, all the rest of them are on VLAN 1. So I can go ahead and add a new rule here on the bridge, and put VLAN 9, it's going to be tagged on port SFP plus 1, my trunk port. So now that's a tagged port there, it's an untagged port here. The only thing I have missing now is the bridge itself, because I want the bridge itself to do management on VLAN 1. So for that one, I come over to interfaces, and I hit a new interface that is type VLAN. Call it VLAN 1 management. Its VLAN ID is 1 on the bridge. Make sure you pick bridge, by the way, not one of the sub interfaces. And then I should be able to hit apply, and that should come up now. Now I should get an IP on management interface, which I have. This one will time out eventually. It'll become on the management interface instead of on the bridge. And then it automatically added this VLAN entry here, so VLAN 1 is tagged on the bridge. So same process for me for all the VLANs on the CRS-305 and the CRS-312 to make everything match up with the CRS-328 that I already have, and I get out with my life. My CRS-312 is up and running now. It's been running for a few days now, just handling my workstation upstairs mostly. I'm slowly starting to move over machines onto this switch from the CRS-328, especially ones that were formerly 2.5 gig capable and weren't running at their full speed. So I also just ran these 3 wires here, which are going to go to my 3-node cluster. So in a past video series, I worked on 3-node clusters using some really low-end hardware, and I got some 2.5 gig NICs for those guys, so I can do somewhat better cluster replication, stuff like that. So that's going to come along in a future video, I'm sure. I also want to make a video on Proxmox SDN, so that's high-speed networking would be good for that, so I can run that over these switches. So big thanks to Mikrotik for sending me the switches in this video, the CRS-312 here and the CRS-305 I got upstairs. They've been very helpful in expanding the high-speed capabilities of my network. So now I can edit off of my NAS at 10 gig instead of I was doing 2.5 gig before, but not even 2.5 gig most of the time because I didn't have enough 10 gig ports on the CRS-328, so I kept having to switch between 1 gig and 2.5 gig depending on what else I was connecting. So now I'm connected at straight 10 gig, no messing around with it depending on what other things I'm testing. I actually have extra 2.5 gig ports I can use for testing devices, which is great. I need to rely less on proxy footage when I edit over 10 gig than when I edit over 1 gig. So at 1 gig, the editing is very choppy, editing over NAS. Editing at 2.5 gig, it's better, but at 10 gig, it's a lot better. Same with gaming. I game off my NAS as well. I was gaming at 2.5 gig just fine, but loading times are a lot better at 10 gig. So if you guys want to see more cluster stuff, more networking, stuff like this, feel free to leave a comment down below. If you have a topic suggestion for me, what to do with this switch, some more unique things to try. What else? I have a Discord server linked down below for that if you want to chat with me. I have a Ko-fi. It's kind of like a Patreon, except it's a one-time thing. And as always, I'll see you guys on the next adventure.